Good afternoon, students. Today we are going to paper 6, unit 19, chiral auxiliary controlled methods. Auxiliary is auxiliary, chiral auxiliary. Chiral auxiliary is the outside chemical substance which can temporarily associates to substrates and give the direction for asymmetric synthesis. After completion of synthesis of asymmetric synthesis, it is generated in its own form. Okay, what is chiral auxiliary? Chiral auxiliary is the chemical outside substance. Then they give okay. It's the chiral auxiliary, the chemical outside substance, uh, purely chemical outside substance, which is temporarily associates with the substrates, give the direction for asymmetric synthesis. After completion of asymmetric synthesis, it is generated in its own form. So chiral auxiliary is involved in the chiral auxiliary can be recorded in the used the P star A star P star A star P star A star can be separated by from dash numeric by products by usually chromatography methods. The following examples illustrates the auxiliary controlled asymmetric synthesis. Alkylation of chiral enolates. First one is alkylation of chiral enolates. Calculation of chiral units. So the most widely used asymmetric alpha substitution of carboxylic acid is carried out through an acylation derivatives of S2-hydroxymethyl pyrrolidine. S2-hydroxymethyl obtained by reduction with lithium aluminum hydride of S-pyrroline. It is used as a chiral auxiliary reaction of S2-hydroxymethyl with propanoic acid anhydride followed by the treatment with lithium disulfiramide. Ethylation and hydrolysis gives R2-methyl butanoic acid in 84% of enantionic excess. The overall reaction may be considered as a C ethylation of propanoic acid. S minus proline. So naturally occurring with this S minus proline when reacting with the lithium aluminum hydride then gives OH S2-hydroxymethyl pyrrolidine. It is a act as a chiral auxiliary. It's a chiral auxiliary. It acts as a chiral auxiliary. When acetic anhydride there is a when reacting with this chiral auxiliary, imprints of this chiral auxiliary, when reacting with the lithium diisopropylamide, then followed by ethyl iodide, then followed by hydrolysis. First one is chiral auxiliary, second one is reacting with base, third one is alkylating agent, fourth one is hydrolysis, then gives R2 methyl butanoic acid. So it gives 84 percentage of enantiomeric excess will be formation takes place. So when this is in presence of chiral auxiliary, they gives 84 percentage of enantiomeric excess. When I am taken in this chiral auxiliary mechanism for this reaction, in this chiral auxiliary reacting with the acetic anhydride, acetic anhydride, then gives then gives SN propyl propanol to hydroxymethyl pyridine. When this compound reacting with lithium diisopropylamide base, then gives E jet chiral enolate, then gives jet chiral enolate. The structure of jet chiral enolate is one, two, one. This is jet chiral enolate. This jet chiral enolate reacting with ethyl iodide. So that alkyl group approaches here from bottom side only, approaches from bottom side only, then gives approaches from bottom side, then gives then product gives 84 percentage of non-numeric excess and chiral auxiliary generates in its own form. The first step in the first step N-S2-hydroxymethylpropanate is converted to N-propanoyl 2-hydroxymethylpyridine, which can on deprotonation with lithium disulfonamide yield the chiral enolate. The chiral enolate exists almost entirely as a Z isomer due to repulsions between the oxygen ion and the chiral enolate, the forced into the conformation with which the carbon-carbon double bond is predictory to the ring uh, plane, and the two oxygen ions are minimum apart. In this conformation ring phase, the enolate is shielded by ethoxy. Therefore, ethylation occurs on the surface. Top is ultimately gives the predominantly R2-methyl butanoic acid is the product in 84% of enantiomeric excess. Next one is alkylation of chiral enolates. Alkylation of chiral oxides. There are several variations of alkylation of chiral azienolates. The alkylation of carboxylic acid through a chiral oxazolines has been extensively investigated. The chiral auxiliary has been obtained by the selective methylation of primary alcoholic groups in SS1 propyl 2 amino propane 1,3 diol by product in the formation of antibacterial agent methanol. So here we are discussing this. Which is SS like when this compound reacting with then gives CH3. Next to then gives 2-methyl 4-hydroxy methyl 5 phenol oxazoline. Then this compound when reacting with sodium iodide then reacting with methylation, then gives this chiral auxiliary. So chiral auxiliary. So alpha alkylation of 2 phenylpropanoic acid. Then phenyl, then the product is phenyl propionitrile. This phenyl propionitrile reacting with Cl in ethanol, then gives with this compound reacting with this chiral reagent, chiral auxiliary, this chiral auxiliary then gives it in this compound. When this compound first one lithium diisopropylamide, second one N49 iodine, third one is hydrolysis, then gives that 6% of financial markets and the chiral auxiliary also update. So when this compound reacting with the lithium diisopropylamide, then the product is phenyl. in this compound reacting with the alkylating agent like N tertiary N-butyl iodide. Then after hydrolysis, then gives our product 86% of enantiomeric excess and characterize generated. Next one is alkylation of chiral hydrogens and chiral imines. Alkylation of chiral hydrogens. Then this chiral auxiliary reacting with this compound reacting with nitrosation on nitrogen. This compound of sodium iodide followed by methyl iodide, then gives methoxymethyl. This is lithium aluminum hydride, then gives SAMP SAP. SAMP SAP means S1 amino 2 methoxymethyl propylidine. Yes, 1 amino 2 methoxymethyl propylidine pyrrolidine. This is called SAMP. So alkali alpha propylation of we are going to 2 pentanone 2 pentanone when reacting with this in presence of SAMP, then lithium dipolyamide, then reacting with the propyl N-propyl iodide, followed by hydrolysis, ozonolysis, then gives our again sample, then gives chiral auxiliary like otherwise you take water hydrolysis, then gives sample methoxymethane plus the product is 7 C2H5 nitrogen. They gives 62% of enantiomeric excess will be formation takes place when it is. So mechanism for this reaction when this compound reacting with SAMP, then the product is chiral hydrogen. Then this chiral hydrogen reacting with lithium disulfide C4H7 iodine. Then the product is NH. In this compound Z azionic, in this Z azionic reacting with the connection takes place, then gives then gives SAP and our product 86 62% of financial markets product given. Organization of means when cyclohexanone reacting with the this chiral axillary when this compound reacting with the lithium dispropalamide. Second one is lithium methyl lithium. Then Third one is hydrolysis, then gives 87% of natural excess and calorize the product. Mechanism for this reaction is when cyclohexanone reacting with this chiral auxiliary influence of acid medium, then gives when this compound reacting with lithium disulfide, then followed by methyl iodide, then gives reacting methyl iodide. Alkylation takes place of top side of the double bond, then gives then hydrolysis, then gives our product is then gives our product is 87% of an excess will be formation takes place. Last notes come for symmetric induction. One come up for Glass notes, one come for symmetric induction. Glass notes when so this is a chiral auxiliary. Relance nodes are useful for one come for symmetric induction. The electrophile and the nucleophile attacking at carbonyl carbon with respect to chiral center at fourth position. So this is a one, two, three, four. So addition of nucleophile at carbonyl carbon with respect to the chiral center at fourth position, according to prolongs major conformation, and that carbon ester carbonyl and ketocarbonyls are anti to each other, and and a large group at chiral center is in plane. Um, at chiral center, medium and small groups are out of the plane. Is a prolonged conformer. So prolonged conformer means they are ester carbonyl, carbonyl, ketone carbonyl, and a large group chiral center must be in plane, and the ester carbonyl and keto carbonyls are added to each other, and large group large group at medium and small groups are at chiral center in out of plane is present. This is a major conformer. So this is when we convert it to this compound. So when this compound, so now we are going to when this ester, when this ester reacting with Grignard reagent, reacting with Grignard reagent, magnesium halide. So when this compound, when this ester, when this ester in existing in more stable belongs conformer, when this compound, then when alkyl magnesium halide approach the ketocarbonyl from small group side only, from small group side, from small group side, then the product is after hydrolysis, the product is the major product will be formation takes place. This reaction, the chiral center and the reaction site are in the 1 and 4 position, and therefore in this example of 1 comma 4 asymmetric induction, since the chiral center and reaction sites are separated by the 3 bonds, asymmetric induction usually allows to moderate when large group when large alkyl group is a tertiary butyl, asymmetric induction is increases. So when this is a general example, when we are going to another example to explain asymmetric induction, 1 comma 4 asymmetric induction. Ester, when this compound reacting with methyl magnesium halide, then the product is top side, hydrolysis, the product is S is major. Major will be formation takes place. Arithmetic disorder. We are going discussing unit 20. Chiral reagent. Control. Catalyst. Control. Method. First one is chiral reagent control method. First one is reduction using chiral aluminum hydrates when phenyl ethyl ketone, phenyl ethyl ketone, when reacting with lithium aluminum hydride. So in presence of a reagent, chiral reagent, presence of a chiral reagent, then the product is 95% of enantiomeric excess formation takes place. So here the it is suggested that one is to one reaction between the chiral diamine and lithium aluminum hydride leads to formation of chiral lithium aluminum hydride. The mechanism is the mechanism is when which is from less spherical, less hindered transient state, then gives so attacking on three phase of carbonyl carbon, that is bottom phase is Then the product is OH and phenyl ethyl hydrogen S compound will be formation. This is a 90% of enantiomeric excess will be formation takes place. Prediction using chiral prediction using chiral alkane orins. Since addition takes place, addition from downside, this is called IPC BBN. When deuterated benzaldehyde in presence of IPC BBN then gives OH hydrogen deuterium is topside, downside is a phenyl. They gives 100% product. This is name of this compound is yes isomer. B formation takes place. So mechanism of this reaction is addition and rephase. That is top phase. Then the product is it is under hydrolysis. Then gives deuterium phenyl and OH plus 9BBN. Product will be formation takes place here. Alpha phenyl formation takes place. hydroboration using chiral chiral alkyl boranes. When cis-2 cis-2-butene reacting with APC pH, then oxidation, then the product is C2H5. What to be done now? Then use about the 98% of financial excess. Then the product is mechanism of this reaction is APC hydrogen when reacting with the so less in the transition state side tagging takes place, then the product is then the product is APC APC C2H5 methyl hydrogen under oxidation hydrogen methyl C2H5. So they gives more than 98% of enantiomeric excess will be formation takes place. Next one is reduction with Grignard reagents. Then gives yes to methyl butyl magnesium chloride, and the product is phenyl OH hydrogen. This alcohol formation takes place. It's a major mechanism of this reaction is when combine these two, then the product is reacting with the chloride That is after hydrolysis, it forms the alcohol. S alcohol is a major product. Reduction of reaction of inflammationally base that is saponification of methyl or tertiary butyl cyclohexane chelate. That is a RDS slow step. This is isomer slow step. Then the product is trihedral intermediate destabilized by syn diaxial interaction. Syn diaxial interaction. This is destabilizing factor. This is destabilized by syn synaxial interactions when this compound trans compound analysis RDS is fast, then the product is there is no synaxial interaction. So this is a destabilizing factor, stable factor. So sulfonification takes place faster. Yeah, reaction catalyzed by reaction catalyzed by A wide variety of reactions, oxidations, reductions, hydrolysis, etc. have been successfully performed by using either isolated enzymes or interacted organisms like yeast reduction, baker's yeast, baker's yeast releases added ions on three phase only. One, two, three. Top is the top is the reface, the nitrogen releases from top side only. No anaerobium, monoanaerobium bacterium, thermo anaerobium bacterium is also releases the hydrogen from the phase oxidation. Liver parts, liver alcohol dehydrase, Rs liver alcohol dehydrase, Rs liver alcohol dehydrase. And the product is ethanol. Yes, product will be pharmaceuticals, please. Next one is hydrolysis. Pig liver ester is then gives this is 91% of financial cases. E2 reactions, E2 reactions of conformationally mobile diastereomer. E2 reaction of conformationally mobile diastereomer. This catalyzes dehydration of 1,2 dibenzoyl 1,2 dibromide dibromethane base catalyzed dehydration of dibromethane. The product is stilbin dibromide. It is existing in two isomers. One is meso, one is active. We are going to discussing meso. Meso conformer. Hydrogen, bromine, then sevophenyle. When attacking of base subtract the hydrogen, bromine, hydrogen. They subtract the proton from here. Then involves in the loss of elimination. Here the two reactive eliminating groups are trans to each other. So therefore, it gives two phenyls are to this phenyl C double bond of phenyls to same side. Hydrogen bromine also same side. Therefore, phenyl CO phenyl CO hydrogen bromine. This is the major will be formation takes place. This olefin of the major will be formation takes place. When we are going to active compound, when we are going to discuss active for active compound, we subtract the proton. The two eliminating groups are trans to each other. And the product is trans olefin. Major will be formation takes place. Trans olefin. Major will be formation takes place. This is a today topic. Thank you.